So what is Docker? Docker allows us to share and distribute software more easily. It gives us a platform to package, ship, and run any app anywhere. To be able to do this, Docker uses containers. You can think of a container as a modified runtime environment for a program, where it prevents the program from accessing any protected resources. It means that we run software in containers to achieve isolation, or basically create sandboxed runtime environments for applications to run in. It's sandboxed in the sense that containers run only in the user space, and programs that run inside of a container can only access the subspace allocated for the container. The container is essentially a private and isolated running process in the operating system. It's important to understand that before Docker, we achieved isolation for software to run in through virtual machines or VMs. So what's the difference between achieving isolation through containers versus VMs? Docker containers achieve isolation at the OS level by leveraging container technology already provided by the operating system. This is not the same as virtualization technology used by virtual machines. With virtual machines, you create isolation by distributing the physical machine's hardware with hardware virtualization, on which then you can install programs and other operating systems. To create and run VMs, you need a program known as the hypervisor, which sits between the hardware and the VMs that need to be virtualized. Each VM comes with a whole copy of an operating system, which is known as the guest OS. Then finally, in the guest OS of the virtual machine is where you get to run your programs and applications. The problem is that VMs are slow to create. When it comes to a Docker container, it gets to interface directly with the kernel from the host OS without any additional layers such as a guest operating system. So it's much faster to build and run containers and be able to run programs or applications inside of containers without any additional resource overhead. Let's go ahead and drill down some more to really understand the problems Docker is solving by allowing us to ship software in containers where programs run in isolation. Imagine that you created this application and now you want to share it with others. It turns out that this is not an easy task. In order to install and use your software, you'd have to tell me what operating system I should have. You'd have to give me a copy of your code, tell me to install various tools and package management systems, download a bunch of libraries and frameworks the application may depend on, then give me instructions on how to configure everything properly, and hope that I've done everything correctly just to be able to run your app. But you can minimize your worries by using Docker. Let's recall that Docker allows us to run applications inside of containers. So where does Docker get all the information needed to build and run an app? The whole process of containerizing an application with Docker starts with a Docker file. With a Docker file, we provide a set of instructions, which are essentially commands that need to be executed to assemble a Docker image. This Docker file in particular is geared towards containerizing a Node.js application. In a Docker file, the first thing we need to do is figure out what image we want to build from. In this case, we're using an image that has version 16 of Node already available from Docker Hub. Next, we need to create a working directory. The working directory is essentially where all the application code will reside within the image. In a Node.js application, the package.json file describes all the dependencies to build and run a Node application. So what we should do is first copy the package.json file over to the working directory, and then run npm install to download all the application dependencies. At this point, we're ready to bundle the app's source code inside the Docker image by using the copy command. If you look at the source code of our small little Node application inside of server.js, you'll notice that the application binds to port 8080. So what we'll have to do is expose port 8080. So when we're ready to run a container from this image, we can redirect the public port from our local host to a private port 8080 running inside the container. And finally, we use the cmd command to tell Docker what to run when the container starts. In this case, we're saying execute the command node server.js, which will start the Node application. With the Docker file ready for our Node app, now we should be able to create a Docker image from it by first going to the directory where the Docker file is and running the following command. We use the docker build command to create a Docker image from a Docker file. And Currently, we're supplying the docker build command with a dot to indicate that the Docker file is present in the current working directory. Finally, we use the -t flag to tag the image we want to create so that it's easier to find and locate by referencing it with our username and the name of the application. So let's go ahead and run this command to build our Docker image. So just to ensure that we've created the image successfully, we can run the docker images command and it should list the images that we have. And as you can see, we have successfully created the image based on our Docker file. Once we have a Docker image, we can publish the image to a public or private Docker registry. And a Docker registry is basically a centralized system that's responsible for the storage and delivery of Docker images. The largest Docker registry, where you can browse hundreds of thousands of container images, is called Docker Hub. To share your applications with anyone publicly, you can publish container images to Docker Hub. Or let's say when you're working in a company and wish to distribute privately, then you can publish to a private Docker registry that's created and maintained by the company. Now that we have some understanding, let's finally look at how to use Docker to our advantage. To start with, let's create containers from images already available in Docker Hub. For this example, let's say we want to test Wordpress, which is a very popular content management system used by many small businesses and bloggers to build their website. So to get started with Docker, head over to docker.com, and once you're there, come to the right where it says Get Started, and then once you're there, scroll down to download the right Docker based on your operating system. Alright, so after installing Docker, go ahead and open up the command prompt if you're on Windows, and open up the terminal if you're on a Mac or a Linux system, and type the following command, which is docker --version. Hit enter, and what you should see is the current version of Docker installed. And if you're on a Mac or Windows, you should also have the Docker desktop application installed. So go ahead and open that up. And once it's open, you'll see that at the moment, there are no containers or apps running. We're interested in testing out WordPress locally. And if you recall, in order to run containers, we need to have Docker images. And at the moment, if we check out our images, we don't seem to have any. So let's head on over to Docker Hub and let's search for a container image for WordPress. All right, so from the search results, let's go ahead and select the official image. And here to the right, we can see that we can use this docker pull WordPress command to download this container image locally. All right, so let's go ahead and copy this command and move on over to our command prompt and go ahead and paste it. Hit enter, and the latest version of the WordPress container image is being downloaded. And this is by default because we didn't specify a specific version to download. Let's speed this up a bit. But what's important to note here are all the hashes that you see on the screen being downloaded by the Docker client. Each of these hashes actually represent a layer that makes up the WordPress image we're downloading. Alright, so with the image downloaded, let's verify that the image is available locally by running the command docker image ls. And as you can see, we have the latest WordPress container image downloaded and available to use by Docker. The other way to verify pretty quickly is by going to the Docker desktop app and going into the images section, and you'll see that the WordPress container image is also visible here. But this image does not have everything we need to fully install WordPress. Based on installation requirements for WordPress, this image only has PHP and WordPress available. It unfortunately does not have a database, and WordPress needs MySQL DB to store its data. But this is an easy problem to solve. We can download an image of MySQL and run a MySQL container along with the WordPress container and basically link those two containers up to be able to fully install WordPress and test the application out locally as we first intended. All right, so let's go back to the command prompt and execute the command docker pull MySQL. So the download is now complete, and we can see that the image is now visible here. With both images downloaded, let's go ahead and create a network. We'll create the network first so that both WordPress and MySQL containers can run under the same network. All right, so let's go back to the command prompt and run the following command. Hit enter and let's create a network called DockerNet. Next, let's go ahead and create a WordPress container by running the following command. All right, so basically we're using the docker run command to create a container called test WordPress from the WordPress image that we downloaded. And this container that we're creating, we want it to run inside of the DockerNet network that we created before. Also, we're mapping port 8080 from our local host to the port 80 exposed by the WordPress container. So this way we can go to localhost port 8080 to access WordPress that's running from the container. And finally, we're going to pass the D flag to run this command in detached mode. Essentially, that means we're going to run this command in the background. So let's go ahead and run it. So we have an output with no errors. That means we should have a WordPress container running. Now, similarly, we can run a MySQL container by executing the following docker run command. The only new thing here is the -e flag, which is used to pass in environment variables required by the container. In this case, we're setting the MySQL root password to be set to password. And we're initially creating a MySQL database called WordPress. Let's go ahead and run this command. And as before, we see an output and no errors. Now, jumping back to Docker Desktop, we can see that the images are indicating that they're currently in use. And let's go ahead and go to the containers and apps. And guess what? We have 2 containers successfully running, and we should be finally able to access WordPress by going into localhost 8080. All right, fantastic. We're officially testing out WordPress locally by running it in a container. I'm going to proceed with the installation by selecting English and clicking on continue. Now it's asking me to enter some database credentials, so let's go ahead and do that. All right, so for database name, we're going to use WordPress because that's what we specified when we were creating the MySQL container. And for username, we're going to use the root user that is created by default by MySQL. And for password, we're going to leave it as password because that's what we set the root password to be. Finally, for database host, we're going to change it from localhost to the gateway that we specified when we created our network, which was 192.168.0.1. And finally, let's go ahead and leave the prefix as it is for the table, and we're going to go ahead and click submit. Awesome. It looks like WordPress was able to communicate with the database, and we're ready to run the installation. So let's go ahead and click. All right, so it looks like that was a success. Let's go ahead and enter the information needed. For site title, we can say something like my blog. And since this is really just a test WordPress, we can use some simple username and password such as admin. And I'll just use admin for the password again. And of course, I don't recommend you do this for a production environment. Once again, this is just a test. So let's go ahead with that. And we're gonna confirm to use a weak password and enter an email address, and then go ahead and click install WordPress. Excellent. So we have successfully installed WordPress. Now we can finally try to log in. All right, so recall that the username was admin and the password was also admin, and let's give it a try. All right, so we were able to log in with our admin credentials, and what you're seeing here is the backend admin dashboard for WordPress. Let's also see how the site looks like from a user's perspective by going into my blog and visit site. All right, so it looks like WordPress has applied some default theme. For now, let's go ahead and get back to the admin dashboard, and let's try to create some posts. All right, so we're just gonna click on posts, and here, let's click on add new. All right, so in the editor, we can go ahead and just put in a dummy title such as my first blog post. And for the content, maybe I want to just put some dummy text. Let's give that a try and let's go ahead and save this. All right, looks like it's saved. Let's go ahead and view post. And yeah, it looks like the post is now available. To conclude, let's head on back to Docker Desktop and see what happens if we were to stop a running container. For example, we have the Mysql container right over here, and let's go ahead and click on the stop button. Okay, so as you can see, the Mysql container is no longer running. Let's get back to our WordPress site and see what happens there. All right, so what I'm gonna do, I'm just gonna hit refresh. And here we go. We see an error message saying that error establishing a database connection. Okay, then let's go back to the Docker desktop application and let's go ahead and start this application, the Mysql container, back up. All right, so I'm gonna hit the play button and now it's running again on port 3306. All right, so let's go back to our blog and hit refresh again and we're back. WordPress is able to connect with the Mysql container that's running. We were able to achieve our objective of testing out WordPress locally by using Docker. And by running containers, we never had to install any WordPress dependency directly in our system. Even if we had incompatible versions of PHP or Mysql installed in our system, it would not have mattered anyway, because containers run as isolated processes in the system. In addition, we were able to link two containers together to achieve a fully functioning system.